Kubernetes was supposed to make infrastructure cheaper. Instead, the average enterprise Kubernetes bill grew 40% year over year in 2025 and 45% in 2026. Not because teams are running more workloads, because they're running workloads inefficiently. Over-provisioned CPU requests. Memory limits set to just in case. Idle nodes running 24/7. Orphaned persistent volumes nobody deleted. The FinOps Foundation reports that 68% of Kubernetes spend is waste. Today, we show you how AI agents fix this automatically. Let's break down where the waste hides. Over-provisioned resource requests account for 34% of waste. Teams set CPU requests at 2 cores because someone said, better safe than sorry, actual usage is 0.3 cores. Idle nodes are 22%. Autoscaler minimums set too high, or nodes that never scale down because one pod has a restrictive anti-affinity rule. Orphaned resources, PVCs, load balancers, static IPs 18%. Wrong instance types 15%. And used namespaces 11%. Every category is fixable. None require human intervention at 2 a.m. AI cost optimization agents connect to your metrics stack, Prometheus, Datadog, CloudWatch, and build a continuous model of actual resource usage versus requested resources. They analyze 30 days of historical data minimum, accounting for traffic patterns, seasonal spikes, and batch job schedules. The agent generates a utilization heat map for every pod, node, and namespace. Where actual usage is consistently below 50% of requests, the agent flags it. Where nodes run below 30% capacity for more than 4 hours, the agent flags it. Where resources haven't been accessed in 14 days, the agent flags them for cleanup. Here's right-sizing in action. A payment processing service running in production. Original configuration, 2 CPU cores requested, for gigabytes memory, 3 replicas. Monthly cost, $847. The AI agent analyzed 60 days of metrics. Actual CPU usage, 0.4 cores peak. Actual memory, 512 megabytes peak. Recommended configuration, 400 millicores CPU, 512 megabytes memory, 3 replicas. Monthly cost after right-sizing, $124. 85% cost reduction. Performance metrics unchanged, P99 latency, error rate, throughput all within baseline. The agent didn't guess. It measured. Node pool optimization is where the big savings live. One e-commerce platform was running 12 M5.2's large nodes with 31% average utilization. Cost, $14,200 per month for the node pool alone. The AI agent recommended a mixed strategy, 8 M5's large on-demand for baseline workloads, for spot instances for batch and stateless services. Average utilization jumped to 72%. Monthly node pool cost, $6,100. 57% reduction. The agent also configured the cluster autoscaler with tighter bounds, minimum 3 nodes instead of 6, maximum 10 instead of 15, based on actual traffic patterns. Automated cleanup runs continuously. The agent scans for orphaned persistent volume claims with no active pods, found 23 in one cluster, costing $400 per month in storage. And used load balancers, 7 found, $350 per month. Static IPs attached to terminated instances, 14 found, $140 per month. Namespaces with no active deployments for 30+ days, 5 found, various associated costs. Total automated cleanup savings, $2,100 per month in this single cluster. Every deletion goes through a safety check, 7-day grace period, notification to namespace owners, and automatic rollback if a deleted resource is referenced within 30 days. Safety is non-negotiable. AI agents operate within guardrails you define. Never reduce production resource requests below the 95th percentile of historical usage. Always maintain 20% headroom above peak observed usage. Require human approval for any reduction exceeding 50%. Auto rollback if P99 latency increases more than 10% after a change. Never delete resources in namespaces tagged production critical without explicit approval. These guardrails mean the agent optimizes aggressively on staging and development environments where 70% of waste typically lies, while being conservative on production. You get the savings without the risk. 3 real results. Case 1, SaaS startup, 3 clusters, 41% cost reduction in 60 days, 0 performance incidents. Case 2, financial services, 12 clusters, 38% reduction, required compliance review before auto-applying production changes added 2 weeks but still completed. Case 3, media company, 27 clusters across 3 cloud providers, 52% reduction, saved $1.2 million annually. The pattern is consistent, 30 to 50% savings within 90 days, with the first visible results in 2 weeks from staging environment optimization alone. Your 4-week implementation roadmap. Week 1, connect the AI agent to your metrics stack and billing data. Read-only mode, no changes yet. Week 2, received your first optimization report. Review recommendations, adjust guardrails, identify quick wins in dev and staging. Week 3, auto-apply staging and development optimizations. Measure performance impact, there shouldn't be any. Week 4, enable production optimization with full guardrails and human approval gates for large changes. By week 6, you'll have a monthly savings report that FinOps and engineering leadership will both celebrate. 68% of Kubernetes spend is waste. That's not a typo, that's the industry average. AI agents turn that waste into savings automatically, continuously, and safely. You don't need a FinOps team of 10 people manually reviewing dashboards. You need an agent that watches your metrics, understands your patterns, and optimizes around the clock. Start with a read-only analysis this week. The report alone will justify the next step. I'm AI DevOps Daily. Next episode, we explore GitOps and why it's the foundation of modern infrastructure management.